So for this video, we're going to keep going over electron counting. I just want to present you guys with some more weird examples, what I like to think of as weird examples. The first one is an oxo compound. So what does this look like? Well, we have ruthenium with 2 bipyridine ligands. And notice how I can just abbreviate bipyridine with that nitrogen just kind of bound to a carbon chain on another nitrogen. So this is a common abbreviation for a chelating ligand or something like bipyridine, which we have to remember is a neutral 4-electron donor. And then we have a chlorine and then a terminal oxo. So this is what the oxo looks like right here. How do we count electrons for this metal center? Well, we kind of push electrons back to the corresponding atoms. Notice the BIPs will come off as neutral ligands. The chloride is going to come off as an anionic ligand with a -1 charge. Now the oxo is a little different. It's going to come out as an anionic ligand, but here it has a 2- charge. So if you look at the formal charge of the oxygen, right, that's 2-. So we have to figure out what's the oxidation state of the ruthenium metal center. So here it's actually ruthenium 4, because we have a +1 charge here and we have 2 anionic ligands, so it's ruthenium 4. So that has 4 d electrons. Now let's count the amount of electrons that are given to the metal by the ligand set. That is 2, 4, 6, 8, 10, 12, 14. So we have 14 electrons from the ligand, so this ends up being an 18-electron complex. So that is a terminal oxo ligand right here. The next one I want to look at is a terminal nitride. So this is a weird compound. This is a ruthenium with a triple bond to a nitrogen, and it has 4 methyl groups. And it has a net positive charge. So what we can do is we can push electrons back. So here we're going to push actually 3 pairs of electrons back to that nitrogen. So we come up with the nitrogen popping off the metal center, and this nitride ligand is actually going to have a 3- charge. Each one of these methyl groups is going to have a -1 charge. So if you push electrons off the methyl groups, you'll get something like that, with an carbanion being formed, and we have the plus charge. So this is actually a ruthenium +8 species, and that has 0 d electrons. So let's count electrons for all of the ligands, and we'll see that we have 2, 4, 6, 8, 10, 12, 14. So we have 14 electrons from the ligands, 0 from the metal center. So this ends up being a ruthenium 8. And it's a 14-electron complex. And then the last one I want to go over has a ligand that sort of looks like bipyridine, but here notice there's a carbon, so there's not a nitrogen. When we push electrons back to the nitrogen, we end up with something that looks like this, where there's no formal charge. So this is a neutral ligand. But when we push electrons back to that carbon, we actually generate a carbanion. So this ligand is called phenylpyridine, and it is an anionic, so it has a -1 charge, and it is a 2,4 electron donor. So it's an anionic 4 electron donor. It's next to this NH3 ligand, this chloride ligand. This is an anionic 2 electron donor. This is a neutral 2 electron donor. So we end up having platinum 2, and platinum 2 has 8 d electrons, and then if we count the electrons donated from the ligands, there's 2, 4, 6, 8. So there's 8 electrons from the ligand. So this ends up being a 16 electron complex.